All right, man. Before we get started, I'm just gonna show you real quick the overview of what I did. Really, all I did was create a coil on a plane, choose a diameter, right? And then you can tell this program to make triangular or circular profiles. You can give angles, so you can kind of see where I'm going with this, right? So negative 1.77 is what we go with, and then I'm gonna choose I'm gonna be cutting in, so it's gonna be the female thread, right? So I want it to look like that when it cuts, like the negative space. And then I gave it a pitch. So I'm just gonna make it like maybe 10 millimeters, and then it pinches 0.9, I believe. Yeah. And then the size of the feature, we're gonna make it about 0.9 as well. And then I'm going to use that as a cut tool, because you can make a new body or you can cut into something. So now that you kind of know what the whole point is, I'm going to start a sketch here. How to make a revolved body starting and then the idea here is that this line and the vertical are the arctangent of 1/16 divided by 2, because this goes for every 1, it goes up 16. So we take the arctangent, which is adjacent divided by hypotenuse. So you probably remember that. Come here to here. Let's say 1.77. I think that's what it is. Yeah, I did that earlier. 1.79 actually. I hate how this goes up here. We probably don't need to do this because the bore is so subtle, and this is such a hack that we can probably just bore straight by picking a size that's equal to in between the small and big diameter. So we're doing 1/8 thread. So that's between 9.7 and 8.5 millimeters. So we can just get in the middle there and bore it at like, 0.8. I lost myself. No, 8.9. No, 9.1, 9.2 will be a good bore. Because we're going to cut into it anyway. And it's plastic on plastic. And we're going to go a little bit bigger because of FDM. So I just chose to go this way for now to kind of show if you want to be more precise. But our big diameter is going to be 9.7. So we're going to make that 9.8 because printers. Right, I think this is how you do it. 9.8. Fix my whole drawing. Great. Oh man, awesome. This should be fine. Because this should be about, if this is 16, if I go from here to here, and I say 16, and I break the drawing, of course. And this should be not quite. It's only 0.2, it should be less. Anyway, let's stay there for now. I'm not going to troubleshoot that shit. So we do the revolve. Along. Profile crosses the revolve axis. Okay. Give me a little hole there, whatever. I thought it was okay if it crossed. There we have our part with our... I'm so bad at this. My dimensions. Oh, this is why. It has to be 16 from here. Where's the tool for its dimensions? There we go. This is 16. There we go. Now this should be 8.9 or something, or 8.7. Not quite. Fuck you. Okay. Well, I'm sorry to Darcy. Hopefully she's not listening. We go back to this revolve. Oh, here we go. Stop sketch. Anyway, what I'm going to do now is I'm going to come here, create coil, bottom plane, if that's the bottom. Come here to the diameter that we gave it, which was, what did we decide on? 9.8. So, wait, did I fuck that up? This is diameter, but I told it it was a radius. 4.9. Oh, the letter D does it. Sweet. Is there a way to make those coincident? Anyway, I'm sure there is. So we come here, exit, stop sketch. Okay, that's better. We create our coil. Hopefully you can follow along this fucking disaster, man. 9.8 diameter. I'm going to say it was height and pitch, so I want to go for a height of 10 millimeters. And then, let's say 14 millimeters. At pitch, look up the table. Our pitch is 0.907. The angle we decided on was 1.79. Okay, so here's where it gets a little bit tricky, because And then the section size, this is tricky because this thing only makes triangles, so are the triangles, is it 1 millimeter like this, or is it 1 millimeter like this? I have no idea. So this should really be the pitch. But judging by how these things are crossing each other, it kind of leads me to believe that yeah, see, right here, it's like this. It's telling me 0.7. That's the height of the triangle. So I could actually come here into my chart and then say that D for 1/8 D1 to D. No, that should really be H2. H2, the height of the thread is 0.581. So we're going to do that. Now, right now we're hugging the inside of that diameter, but we can tell this that we want to be on the center or we can be on the outside. See? We want to be on the center. It's going to be hard to tell which one is best until I can print this out and test it with a fitting. I don't actually have any fittings available, so you can play with this to see how you get it. Everything looks good. We have the right diameter. I think I have the right rotation. Let me look at this. Let's do a new body. It looks like something would tighten onto there, so that's good. Yeah. As I turn something clockwise in there, it would. God damn it. Yeah, we'll sink in. Okay. We're gonna do a cut. You can also play whether you want to cut or you want to create a new body. That kind of stuff. Then press OK. There you have it. Now, there are actually going to be some non-manifold sections right here. I suspect you could have one that looks manifold. That looks manifold. So this may actually print out. And that's the idea. Now you have threads. This one looks a little bit tighter than mine that I did earlier. So I wonder if I screwed something up. You have to be careful because when you're looking at these charts, in the major diameters, you have to think of the diameter, but what I did was revolve the radius, so I may have screwed that up. And but it looks about right. Because if I come here into my sketch, if I come here into my sketch, I have 9.8 here, and then this one, oh yeah, 8.8. So does that jive? $9.8, close. We're close, so that's not too bad. All right, there you have it. Magic. Also, it's hackish as fuck. I had another technique that was really neat for creating threads. What I did was, oh, that doesn't look manifold right there. Maybe it is. Maybe you can just slice the bottom ½ millimeter. No, it is manifold. It's just a little nugget. I had another method that was really cool method for drawing threads on the inside, but Fusion doesn't know how to handle a 2D profile well. So I drew a tooth. First I drew a triangle that cut a fine dimensionless line around the entire inside, essentially creating a spiral, a one-dimensional spiral, well, a line spiral. Then I came here and I drew a tooth. I actually drew a tooth like this, and then I gave it the right dimensions, and then I started cutting around. But as I started following the helix, the polygon would actually rotate, so then it would like start doing these weird things, kind of like a roller coaster. I couldn't get it to stay straight, so this is the best we have for now. There's probably a better way, but I slept like 3 hours last night. Alright, buddy. I hope this wasn't as confusing as it seems to me right now.